Well, welcome everyone to our March 6th North Houston Space Society meeting. We have, these meetings every month. We've also taken go on tours. We went on a tour of NanoRacks last year. And of course, since then, we haven't been able to go on tours because of COVID, but looking forward to doing many more activities like that in the future. So our plan is I have a few opening remarks. Then Greg is going to go over the recent space news. And then we have our featured speaker, Hugh Blair Smith, who's the author of Left Brains for the Right Stuff, Computer Space and History. And he worked on creating the Apollo guidance computer and actually a lot of the necessary inventions to make the computers get us to space. And it's really amazing how much I've been working on reading the book. So it's been really a good book. I definitely recommend it. Then after that, we'll have some Q&A and then a chance to share any personal space experiences since the last meeting. We have a few people that I know that are participating in the Inspiration 4 contest for that one of those seats on that Falcon Dragon mission later this year. I thought I might show you one of those videos. And then we'll wrap it up about 4. So first off, the vision of the National Space Society, of which the North Houston Space Society is a chapter of, is people living and working in thriving communities beyond the Earth and using the vast resources of space for the dramatic betterment of humanity. And the way that we hope to accomplish this is mainly through education and promotion of information about what's going on in space and the potential that it has. We have a member of our group that made the transition from being a project manager in oil and gas and is now working at Blue Origin. And we have several other people that are looking at pursuing a career in aerospace. And, it's not just about keeping them exciting, but also educating their parents and friends about the potential it has too, so that they continue on that path. So welcome anybody that shares this vision. Go to northhoustonspace.org. You can sign up for an email list. We put up the information about each of our meetings there as well. Also encourage you to join the National Space Society and just give you a chance to connect with other people that are, share this vision of humanity branching out to the stars. So this meeting is being recorded and we're going to post it on our website, YouTube, and other places. And just want to let you know you can stop and start your video and mute and unmute just in the bottom left-hand corner. At times, we may turn off the ability to unmute yourself just to make sure that we give everybody the best experience possible. Okay, with that, Greg, let me pass it over to you.
Okay, thank you. So let me share my screen here. All right, I'm going to cover the space news as of March 6, 2021. This is covering about the last month since our last meeting. The main theme here today is Mars, because there's 3 missions to Mars. This picture of Mars, in fact, was taken from the Chinese Tianwen-1 mission shortly before it arrived and was inserted into orbit. So it turns out that the old movies where the Martians came to attack us is kind of went the other way. We're definitely going in the direction toward Mars. So there are 3 missions that have arrived there: United Arab Emirates, China, and the United States. Right now, we're the only ones that did a landing. United Arab Emirates probe essentially is in orbiter. It's a satellite. It's going to be monitoring the weather and so on. I'm not going to spend too much time on that. I covered it back in last August. China, right now, is only just orbiting, and I'll talk more about that in future meetings when they actually have their lander. We'll focus a lot on the U.S. Mars landing. As a reminder, the reason they all 3 arrived all there at about the same time was there's windows that come every 26 months, kind of a favorable alignment of planets. where going from Earth orbit to the Mars orbit, there are times when you can do a fairly minimal energy coasting run to switch orbits here. And so, for instance, the planets in this case are going counterclockwise in this view around the sun. From this point on the top of the Earth orbit here, we launch, and that meets up with Mars, which also meets it at the same time. So that only happens every 26 months, and that's why all three of these missions went at about the same time. These trips all take about 200 days. They went about 300 million miles. So the UAE mission, as I mentioned, is mainly focusing on weather and monitoring the atmosphere and analyzing the atmosphere. In fact, actually, a lot of people think there's going to be some pretty good science coming out of this. This was done in collaboration with some American universities. They really have a fairly impressive space program for a small country. They have a program called Mars 2117. They're trying to build a world-class space sector, and they appear to be on their way to do it. It's amazing because they're so small. They only have 9 million people, and actually only 1.4 million of those are actually citizens. The rest of them are contractors. China, we'll really talk more about that in the future. As I said, they're putting a rover on Mars as well, but they're not going to get there until May or June. Right now, they're just sitting in elliptical orbit. The lander, when it goes, will be landing at a place called Utopia Planitia. There is a large water ice reservoir believed to be under this, that this has been determined from orbit before. So they're going to analyze the soil and rocks and look at the internal structure. Like the American lander, they have subsurface radar looking down for things like buried ice and the geology. And if they do land success, they will be only the third country to do the soft landing on Mars, and only the second to, in fact, drive a rover. So let's get on to the NASA Mars mission. This is a big one. It went on an Atlas V rocket. It is the most advanced robotic explorer we have yet. It's based on a Curiosity, which is a rover that arrived there in 2012. And interestingly, it is still active, and that's because it was so reliable. They reused about 90% of the parts from the Curiosity rover into Perseverance, which is the new one. But that other 10% made quite a few advances. To put things in perspective here, NASA has landed on Mars 9 out of 10 tries, so they have a very high success rate on this. They know what they're doing. Only one other country has even managed to land on Mars successfully. Plenty have landed unsuccessfully, too fast. They landed in 1971, so was that 50 years ago? And that they had a successful landing, but the lander only lasted 2 minutes. So really, NASA is clearly the leader in this area. So the Mars rover itself, it's about a ton, about the size of a car. It is nuclear powered, just like Curiosity, or for that matter, like the Voyager probes. They have a plutonium-based heat source that just decays about 2% a year. These things have the advantage of being very reliable. I mean, you're pretty much just generating heat. It's not a reactor. It's just generating heat. It decays about 2% a year. The prime mission of this thing is to spend at least 3 years in the Jezero crater. This is an ancient lake bed and a river delta. The crater itself is about 30 miles wide. The goal is to search for ancient life. That is, maybe fossil remains or chemical remains that indicate the possible presence of life in the past. And they have a lot of instruments for doing that. Of course, along the way, they're also doing a lot of things that are going to help for future Mars settlement, such as detecting the presence of water. They will be drilling for samples, and they will be caching. They're going to stick them. I'll show you in the next slide. They'll be sticking them, basically kind of storing them on the rover temporarily, but they're actually going to cache them. They're just going to leave little caches of these samples around on the surface of Mars for another mission to pick up, maybe in 2031. They'll be doing weather and monitoring, as well as their testing for ancient life. Also, things like testing spacesuit samples right here on the front. In fact, what they do is they can actually blast that with a laser or something to test it. And they do all kinds of tests associated with the spacesuit samples. One big change is this thing is doing autonomous driving. And that may not sound like much, but think about the fact that, it's a 20-minute round trip communication delay. So if someone wants to say, watch out, there's a boulder, it took 10 minutes for the signal to get there, 10 minutes to go back, you can't drive very fast at that rate. And that really slowed down Curiosity. They figure just having autonomous driving where they can navigate on their own while they're driving, that speeds them up by a factor of about 5. The actual top speed of the thing is 0.01 miles per hour. So they got us maybe 53 feet per hour. But they can keep that up, whereas in the past, the rover Curiosity had to have a lot of stops, or had to stop and look around and think about it and wait for instructions. This is far superior. Some of the scientific instruments that are here. First of all, they have a lot of cameras. There's 22 cameras. They're everywhere, and a couple of microphones. So now you have you can actually hear what's going on there as well as seeing it. They have a fairly tall mast, and they have a zoomable camera. That's the first on Mars. They can see a housefly at 120 yards. They have a laser that can zap rocks. It's mounted on the same mast, and anything within about 23 feet or maybe more, they can zap. And what they do is, in the process of vaporizing the rock sample, they measure the spectra with various instruments, and as a result, they can determine what is there. So this is really a fairly advanced form of determining the composition of the materials on the surface. And then, of course, they have the drills attached to the robot arm. It's about a 7-foot arm. And then they also have some of these other spectrometers attached to the robot arm as well. The sample handling carousel is here. So when the drill picks up a sample, it's about the size of a piece of chalk, for those who are old enough to know what a piece of chalk looks like. And then the robot arm would take that, it would insert it in the carousel here, and it'll actually get stored for a while underneath this thing, and then eventually get dropped off in the cache. Other things going on, the subsurface radar I'd already mentioned, they can go down about 33 feet looking for things like water or geological features. Again, all actually pretty useful for figuring out how to inhabit Mars. They're also doing an experiment for the first in situ resource use. They're going to try to take some of the atmosphere, which is almost all carbon dioxide, try to get some of that and simply just react it to free up some O2 as an experiment. The O2, of course, in the future would be used for rocket propellant or for humans to breathe. So that's actually a pretty important step, is to start thinking more about in situ resource use. Really, you're not going to have any space settlement until you have that. The landing, you're going from 12,000 miles per hour to 0 in what they call the 7 minutes of terror. You're starting off here. There's a cruise stage, which is what got you to Mars in the first place. They separate and they start their descent. The heat shield, of course, is getting very, 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 very hot during this period. Heats up about 2,400 degrees Fahrenheit. The parachute is deployed automatically based on looking at the terrain and figuring out when is the right time. This helped improve the accuracy of the landing quite a bit. So the parachute is deployed. Fairly shortly thereafter, the heat shield is dumped. And then radar and cameras are again matching the terrain against previously stored photos, so they can do their best to land in exactly the right spot. So based on that analysis, they decide when to finally separate from the parachute, drop off what's called the sky crane, and that has a powered descent. It has 4 rockets on it. And they lower it, and it's called a sky crane. And what happens is the sky crane then lowers the rover itself to the ground. This has a lot of advantages, such as not requiring landing legs of any significance, and also not having so much dust flying around on the landing site. And then when they literally cut the cables from the sky crane, and that sky crane flies off and crashes half a mile or so away from there. This is what it looked like. This is the artist's conception on the left here, showing you the sky crane, while it's powered during the descent phase. And the rover, the wheels had not yet been lowered into final position. On the right, I have an actual photo here. This was taken from the sky crane looking down onto the rover. You can see the 3 support cables, clearly here. The wheels in this case have already been deployed in the downward position. This other cable is what is for communications purposes. So for instance, this picture was taken from the sky crane and it was transmitted back down to the rover, so that we eventually could see it. So it's pretty impressive. And again, all this had to be autonomous because the whole thing has to happen way too fast. With that 11-minute transmission delay each way. So where did they land? Well, to give you perspective here, that little green dot in the center of this picture is where they landed. This is actually fairly rough terrain all around here. So they managed to pick out autonomously a good spot to land. Their target was a 4-mile wide landing zone, and they managed to get within that. In fact, they were only 1 mile from the center of that. And, there had to be some flexibility. So that was considered quite a success. They found a flat spot. It was only tilting 1.2 degrees. And there were boulders all around it within 35 meters. So this was quite an impressive landing. Um, Shortly after they landed, they started taking panoramic photos, very high resolution, and they pasted them all together. This represents something like 140 pictures pasted together to form this. And you can find these things on the internet. You can see the details if you want to look in more depth. But these are the crater walls here in the distance. And shorter mounds are also available here. So anyway, what is the status here? Well, they managed to land in a flat spot. Then they sent back images and sound recordings already. This particular one is one of the live ones. This was taken from one of their cameras. It also happens to be the background in my Zoom session here. What they've been doing so far is mostly just activating equipment and testing it very, very carefully. It takes several weeks to really get all that done. There's a software update they had to go through to switch the software for doing the cruising to Mars to doing the roving. And that actually takes 4 days. Sounds like a lot for a software update. Worst at Microsoft by far. But they're being extremely careful. They're not even transmitting it. This was a pre-stored. It just needed to be very, very carefully tested stage-wise as it happens. And all the things that have to go on, you start up the instruments. For instance, they deployed wind sensors and that sort of thing. They had to establish communications. There's all the satellites that are around Mars right now are pretty much involved in relaying communications back from this. They have flexed the robot arm, so they know that works. They also took a test drive on March 4th. And in fact, what that looks like is this, where they went a short distance and went in a circle and came back. But the main thing is that proved that all the parts worked. The wheels could rotate, the power could be applied. So everything is really looking quite good. This is quite successful so far. Where are they going? Well, it's interesting to look at the picture at this scale. You can kind of clearly see here that there's a river and a delta, and the crater here on the right-hand side. So they landed where there's a little white spot is over here on the right side of the thing. One of their goals is to spend a lot of time in this delta region, because the idea there is if there was ancient life, chances are pretty good there was flowing water, there would have been sedimentary deposits at all different time periods, and with some luck you'll find something. So they're going to spend a lot of time doing that. So they've mapped out several possible routes. They haven't picked exactly what they'll do yet. But they'll go past some little impact craters and eventually work their way. And depending on timing and success of the mission, they may really take a much longer trip. They eventually could, in fact, get out of the crater altogether. It just remains to be seen. Depends on what they discover and how the equipment holds up. If you want to know where the Perseverance rover is at any time, there's a website for that on the nasa.gov site. You can just do a Zoom search and ask where is Perseverance, and you'll see pretty quickly how to find this site. This is the exact link, but you don't have to write that down. Just do a Google search on where is Perseverance. Landed here. This was the original landing zone, and this, of course, this is that river delta where they'll be heading. And maybe they go up the river or whatever. Think of this as the Mississippi River Delta without water. The helicopter, I'll talk more about that in future news because they haven't launched it yet, and well, it'll be fresher news then. So we're going to skip over that, but it's a fairly interesting story in itself, and all new technology. None of this had been done. No rover has done anything like this before. Most people probably don't realize it, but there are in fact 11 missions on Mars right now. 6 of them are NASA. There's the 2 rovers we've talked about, Perseverance, the new one, and Curiosity, the old one it was based on. InSight landed in 2018. That's not a rover, that's just a lander. It was doing seismology studies, drilling. It tried to drill, it didn't get as far as they hoped. But drilling and getting temperatures and doing weather and there's orbiters, satellites. So they have 3 of those. The European Space Agency also has 2 orbiters as well. So all these satellites are doing typically weather monitoring, analysis of the atmosphere, surveying the ground resources. They're doing all these things. And additionally, the ones from ESA and NASA are also acting as communications relay satellites to get the communications from the rover back. ESA, actually one of those missions is shared with Russia. So they're involved in one of those. India has had an orbiter up there since 2014, and of course there's the new ones. the Arab Emirates and the Chinese mission, which will hopefully have a lander as well. Off to something different. There's an asteroid that just went by last night. I didn't hear if anybody got any good pictures or not. It's about 1,000 to 1,500 feet across. It's called Apophis. If it happened to hit the Earth, that'd be about 1,000 megatons of TNT in terms of its equivalent explosive force. Now that's nowhere near as bad as some of the other asteroids that might hit us. The one that killed the dinosaurs and 70% of all the species on Earth, that was 6 to 10 miles wide. So that was quite a bit bigger than this one. But obviously still this attracts a lot of interest because it's coming close. It passes the Earth about once a decade. It's not really expected to collide with us in the near future, meaning the next century or so. This particular time, it passed 44 times the Earth-Moon distance, so it's still quite a ways away. However, this one is especially interesting because it will pass within 19,000 miles in 2029. That's in the range of our existing geosynchronous satellites. The ones up there in geosynchronous orbits are at about 19,000 miles. So there could be some damage there, or disruption of orbits. Now the astronomers are really interested in this one because this is still a chance to get a really close observation on another asteroid. No missions that I know of have been planned for this yet, but there's been a lot of talk about what to do about it. This is just to help you visualize what it would look like if this thing could just somehow settle nicely alongside New York City. Obviously, this would just be a huge crater if it actually hit. Some other news, the Space Launch Systems, that's been the kind of a long-term government-sponsored program to get a heavy lift capacity. It actually has been canceled out of the Europa mission. Europa is a moon of Jupiter. It has some fairly interesting reasons for going there. This picture shows you an idea of what it looks like. They were pursuing two parallel paths. The one path was with SLS. The other one was with a commercial heavy lift rocket, and that's just the code word for the Falcon 9 Heavy. That's the only one that's actually proven. They do want something that's proven for these missions. Now, if they had gone with SLS, they would have had to delay the launch in 2024, which is when it was planned. And there's several problems with SLS. One is that it has been falling behind schedule, been kind of disappointing for a long period of time. But even if it follows its development schedule, the problem is the Artemis moon program is assuming the use of the SLS, and there wouldn't be any SLS rockets available. Now, there are some impacts on the mission as a result. The trip will take longer. It'll take 5.5 years as opposed to 2.5 to 3 years to get there. The reason is that the Falcon 9 Heavy actually doesn't have as much power as the SLS did. This means it will take gravity assist, so they'll have to pass some planets and get kind of a boost from being pulled along by the planets, and that's why it would take longer to get there. The other thing that would be of interest to the Falcon 9 users, of course, is that they would have to use all the booster fuel. There wouldn't be any reuse involved in those boosters. They just need every ounce of propellant they can get to get the mission going. It turns out that about reusability as used in the Falcon 9 does come with a cost. You have to have about 30% of the fuel reserved for it coming back to land, whether you're landing on the barge or coming back to a land-based launch pad. Either way, it takes fuel to accomplish all that, and that would just there wouldn't be enough fuel even to make it. So they have to use all of the fuel to the booster. It's kind of interesting. You go back to some previous state back in 2014. Charles Bolden, who was the head of NASA at the time, he said that, well, Falcon 9 Heavy may someday come about as on the drawing board, but SLS is real. Turned out he didn't quite get that right. Now for something totally different, a luxury space hotel. There's a company called the Orbital Assembly Corporation, and they've announced an ambitious plan for a luxury space hotel. They'll start building the actual hotel in 2026. Maybe it's available in 2027. Now, this thing is as pictured on the left. It's a 650-foot diameter wheel. They're going to rotate it so that they could get moon level artificial gravity, about a sixth that of Earth. Their plan is to outfit it very much like a very expensive cruise ship. In other words, this is definitely going to be a luxury liner kind of a thing. Eventually holding up to 400 guests. They would build it in stages. They wouldn't have it being as big as that at first. There would be 24 habitation modules, and you could see them in this drawing, kind of arranged around around the structure. Each one of those is 65 by 40 feet, and they're imagining private airlocks. So they're kind of imagining people are just going to go out on spacewalks. So that remains to be seen. But anyway, that's the plan. So where are they now? Right now, they're really mainly producing slick marketing brochures. They're trying to raise money. So there's a big push to get the investment. At least they're doing the thing in stages so that the earlier than the 2026, they would build a 200-foot prototype in low Earth orbit. In fact, they would spin it faster, and they'll build the thing in stages. Now they're advertising as, obviously luxury view. The economics really will depend on Starship being ready. They're showing one here because they need to get the cost. They want to get a lot of people going up to a space station. They're going to have much lower costs than even now. But what they're selling is, besides the accommodations and the views, would also be experiences such as low gravity sports. Here they're envisioning something like a basketball. So anyway, they're out there looking for money. Their economics remain to be seen. I haven't seen many technical details. I got the impression right now it's more getting their name out there and starting to raise money. Another interesting thing is, reusability has been proven by SpaceX as being essential to getting costs down, in particular the boosters, but even the second stages, fairings, all these things. Now, Rocket Lab early on, this is the one originally out of New Zealand, they had based their technology differently. Their claim to fame was the carbon fiber rockets and the 3D printed engines, and they thought that was their big technological edge. And at one point, the CEO said he would eat his hat if they ever moved toward making boosters reusable. Well, as time went on and they saw that SpaceX was doing well with it, they changed their mind, and now they're pursuing the same reusability. So he promised to eat his hat, so he did. And what you're seeing in this picture here is a blender. He did cheat a little bit. He took his hat and he blended it, chewed it up a bit in a blender. He's just about to pour it into a glass to eat the thing. He didn't eat a whole lot, needless to say. His quote was, "This hat is not tasty." Now, this was done, of course, this is actually great PR for them. In fact, what they were doing was launching they're announcing a new rocket called Neutron, which is much bigger than their previous rockets. The Electron rocket they had before could only lift 500 pounds to low Earth orbit. This one will be able to lift 8 tons. They're targeting really all of these constellations of satellites that are going up for internet service. And they want a bigger piece of that pie, or in a hat in this case. So now that brings up a question. How many launches have there been since the last meeting, which was on February 6th? And as almost always, we end up finding that we have a great counterexample with with Starship. The prototype serial number 10 test, it didn't count. It doesn't count as a launch because it was only going up 6 miles, so it was suborbital. In fact, what you're looking at in this picture is a successful test, believe it or not, because the rocket went up, it came back down, it landed on the pad, and everything was just great, except something didn't go quite right. And then at 8 minutes after landing, it blew up and blew into the air. The Twitter feed was quite amusing on this. People saying things about, "Oh, it's the fastest reuse, second launch they've ever seen," so on. Anyway, so what people are doing now is voting on how many launches they think there have been. And it looks like, see, 13% of you said less than 5, 13% said 6. And then there were a bunch of votes here in the 8 to 12 range. Well, it turns out, in fact, this wasn't that busy of a period. Okay. Stop sharing results here. There were 7. And most of them are kind of routine kind of things, like there were several missions to take cargo to the International Space Station, one from the US and one from Russia. The one interesting piece of news was that there were a couple of launches from SpaceX of doing their batches of 60 satellites at a time for Starlink, the internet service. But what was interesting was what really made news was they failed to recover one of their boosters. Now, just a couple of years ago, everybody was amazed that they could launch rockets and they could bring the boosters and land them right back on the launching pad or on a barge. Now it makes the news when they don't do that. This actually does affect the economics for SpaceX. They only have 6 of the Falcon 9 boosters, so losing one starts to be significant. And one thing I will also highlight is that in their 20th Starlink mission, they did recover the booster successfully, and that was usage number 8 for it. So there, and that matches their record so far. So they're doing quite well on the reuse. At this point, we'll end it. Maybe we'd have time for a couple of questions or comments, and then we'll move on to the main speaker.
I thought it was interesting that everybody guessed around the 7, but nobody actually guessed 7 launches.
Yeah. Okay, well, I guess if that's the case, we'll move on to our main speaker, Hugh Blair-Smith. He has a book and the topic of this lecture, which is Left Brains for the Right Stuff, talking about computer space and history. There's been a long history of course, computing being an important part of the space program. And he's just the guy to talk about it. He has an engineering applied math degree from Harvard. He worked at what is now called MIT Draper Labs, which has been involved in a lot of advanced technology things over the years. He programmed the Apollo guidance computer and was involved in the space shuttle control software and even space station. He went off and worked on startups for a while and then returned to NASA. And now he's also working on a science fiction book. And of course, he gives these kinds of talks that we're about to hear. So Hugh, over to you.
Oh, yeah. Oh, good. I am unmuted. That's that's cool. Okay. Well, let me get right in here and bring up the screen sharing, which is that one, and like so. Okay. That everybody get that? My title slide here. Okay. One thing I've wondered about with this title is I haven't had any feedback direct from astronauts about my book, and I'm wondering whether any of them are going to be offended at the thought that they needed more left brains than they started with. But of course, my point is that no matter how smart they are, flying in space and getting and going to the moon and landing and all that stuff cannot be done with well-trained pilots' intuitions. You do need the computers. So that's thought. Okay, let's see. I should be. Oh, I guess I have to click on the thing before. There we go. Okay. So I start off basically what I originally did. This book was going to be just a bunch of little stories, more or less disconnected stories. What was it like to be at MIT at the lab during all this? And in the publishing process, I was persuaded to make it into more of a history with a flow through time that was fairly well organized. So I start off here with long ago, and I don't know how many of you people are familiar with Wan Hu, one of the first rocket men, but we'll have a look at him. Kepler, everybody knows. Cyrano de Bergerac, you know of the fellow with the sword and the long nose, but he was actually an excellent scientist and writer. And then we have the anti-Raj rebels in India, which caused, among other things, the invention of the rocket's red glare. And Jules Verne and Edward Everett Hale. So that's the cast of characters here. Here's Wan Hu sitting in his chair wearing his court robes, and the ignition crew is approaching there with their little torches. 5, 4, 3, 2, 1. That's what was left. And for that reason, solid fuel rockets were not man-rated for another 400 years. Now we have some nice books from centuries. That 1687 was Cyrano de Bergerac, and I'm taking a very silly view of the whole thing. And then we have Jules Verne, and of course you can see that whoever did the cover illustration for Jules Verne does not have much of a grasp of space or zero gravity, but that's how it goes. Then we go to navigation lore from long ago. The magnetic compass, and one reason I'm doing this is I'm going to point out how inertial navigation as we use it in space is really the same thing as dead reckoning on a boat. I don't know how many boat people you are there, but it's sort of dead reckoning on steroids. So the magnetic compass, of course, was what they had for direction. The chip lock.
Lost the sound.
Hello, Hugh. It looks like we lost your video and your sound. We can still see the slide though. Maybe connectivity issue. He might be joining back shortly. Well, while we're waiting for Hugh to come back, I was wondering if any of y'all had happened across this book before this meeting, the Left Brains for the Right Stuff. It's definitely a interesting book. I've been really enjoying it. So if you wanted to kind of see some of the insight into the Apollo era that didn't have to do with astronauts or rockets, but everything else, it's definitely a great book for that. One of the things that really kind of amazed me, he has a rocket, number of launches count per year during the 1960s. And most years have like, 700, 800, 900 rocket launches. A lot of these were suborbital, but it's just amazing the amount of activity that was happening during that time. Let me see if there's a way to get in touch with you.
He's trying to connect. I see connecting to audio, but probably he has some problems with this line.
Okay. Sometimes it takes a little while. Oops. Looked like he disappeared. Yeah. Hmm. Let's see.
If he can email us the presentation, we can show it, and then
Let's see. I actually do have the presentation. It's just
There he is. He's coming on
oh.
again. I can see it.
Awesome.
Yeah. I don't mind waiting. It's cool.
or see me. Yeah, okay.
Okay, cool. And
Huh.
we'll make you a co-host again.
Good. Okay, yeah. I'm sorry about that. In my home office, I have a router, which, and I gather most routers do this. At some point every afternoon, I can never say in advance, am I coming through or not?
I can hear you, can't see you though.
Well, all right. My router is behaving very badly. I'm going to give it another short rest.
Well, Hugh, you want to go ahead and share out your slides again, and I think we were just on slide 6, the navigation lure from long ago. Oops.
You might just be restarting.
Yeah, possibly. Okay. Well, while we're waiting, did anybody have anything y'all wanted to share or talk about? Maybe some questions from the space news update that you might have had since then.
I
Well,
have
one
a
thing we
comment.
started to talk about a little bit earlier was the Martian helicopter. We skipped over that, but I guess I could give a little sneak preview of what's coming. One interesting thing is related to computing and space travel that ties in with the theme of this speaking engagement. The processor that's on that little helicopter is essentially it's a Snapdragon 801 or whatever it is. It's basically a processor that is now used on cell phones, and that is a lot more powerful than the processing that's available on the rover itself, which is the size of a car. And the reason is that the rover has to have radiation hardened electronics to make sure everything goes well. But the helicopter is considered a lot more expendable, much more of a research thing that was thrown together pretty quickly. And so they're willing to take a lot more chances with that. And that's why they went with a commercial processor instead of Snapdragon from Qualcomm that would be in any cell phone. It has a lot more processing power, but the downside of that is it's not radiation hardened. And on the surface, that's a problem for anything in orbit, but especially in upper orbit, or especially on a planet of Mars where there's no atmospheric protection or magnetospheric protection. So they said, well, okay, every now and then, some cosmic radiation is going to flip a bit somewhere and mess up the programming. So what they did is they have one radiation hardened processor that's monitoring the Snapdragon processor. And when it detects any kind of a problem, I don't know what the detailed tests are, but at least they're watching for certain problems. If it happens, excuse me, they'll just simply turn off and reboot the computer. Now, this will be a problem when it's in mid-flight. Immediately, the helicopter would start to drop. But the good news is they can reboot within a millisecond. And so they'll fairly quickly get back up and just keep on going as if nothing had happened. So that's their solution is instead of trying to have super reliable hardware, they're saying, okay, it's going to be low reliability, but it's much more powerful. We'll make that trade-off and we'll simply change the software to be more fault tolerant. That's been a general strategy in general on how do you deal with faulty or unreliable equipment. You can either make it really reliable or you can make the fault tolerance better so that you can recover, and that's what they opted for. Looks like Hugh's back. Hugh, I was just filling in for you, so I'll shut up.
Okay. Yeah, I've got one of those routers, and it's behaving much worse today than in any previous day I know of. But every afternoon, it apparently needs changed. I don't know. I can't imagine how any engineer could have designed any device to work like that. Anyway, So, okay, I guess we're back. Okay, let me get back into the sharing operation here. Oh, well, I'll ask. Let's see. And I'll go from the top there. Oh, hello? From current slide, maybe. Okay. Now, okay. Did you hear any of what I said that went with this slide? Did you see this slide before?
Yes. Uh-oh.
Oh, he moved.
Okay, I just heard you, but
Oh, we can hear you
what-
now. You're
Okay.
good.
Okay, well, sorry about that.
This is the
it's,
slide we
I
left
can't-
off on.
Sorry, what was that?
This is the slide we left off on.
Yeah, okay, we did. Okay, good. Anyhow, so I've just been talking about the various instruments that the various kind of measurements that were made. And let's see, I know I have to click on the screen somewhere to wake it up. Okay, well, that's right. Anyhow, longitude problem, I'm sure well known to you from the book of the same name. What you might not recall is that this is a Royal Navy fleet in 1720 or there, something like that, commanded by His Excellency Sir Admiral Sir Cloudesley Shovel. You can't make this stuff up. And he had a meeting with his navigators, and they, with one exception, they all agreed on the course to follow. Turned out the one dissident was correct, and the whole fleet went on to what you see here. And the problem, of course, was that they did not have the correct time. So after a long period, this wonderful machine was invented. This is Harrison's chronometer, his first model called H1, which is on view now in the London the Royal Observatory in London on the Thames. So it took him a long time to get his award from Parliament. Okay, are we still together?
Still together.
Okay, good. All right. So anyhow, that was about navigation. Now a little bit of computer lore. Calculus, as you may know, is invented simultaneously in England by Isaac Newton and in Germany by Gottfried Leibniz. And they're partisan. I think you can still get into a fight in a British bar or a German one over who is the real first inventor. Jacquard produced the punch card loom, sort of invented punch card technology. And Charles Babbage, we all know about something about Charles Babbage in the 1840s. And of course, all of this was not going to go very far, despite Babbage, without some electricity. So Mr. Volta invented the volt. Mr.
Looks like we just lost the audio.
Oh no. Oh no, not again.
I think if Nathan, you can share the slides,
product.
that would reduce the bandwidth of you, and that would, allow him to communicate better. So,
I think it'll fade it.
Let's give it another go.
you're mute, Hugh.
All right. Let me just, for the heck of it, let me try.
And if you
Okay.
want, Hugh, I have a copy of your slides. I can share them.
Yeah.
Maybe that will save a little bit of your bandwidth.
Oh, well, I've never had troubles with bandwidth. doing this sort of thing. But let's press on for a little bit if we can.
Okay.
Are you hearing me? You hearing me okay now?
Yes.
Okay. Because I don't see any of you. I know there's a view button, but anyway. But on the right, you have Monsieur Jacquard.
Oh,
You're
you'll need
looking
to
at a very
share
fine
out
engraving,
again,
except it's
actually.
not an engraving. It is.
Nathan, perhaps your slide idea is a good idea.
Okay. We'll do that then.
That sort of digital imaging at the time. Okay, and now it says my internet connection is unstable. But let's try to press on anyway. So we covered the beginnings of things, and now what I call the Get Scientific phase. Tsiolkovsky wrote basically everything you want to know about rocket science, but he never tinkered, never handled anything. Robert Goddard here in Massachusetts made his gasoline LOX rocket and did the tinkering. In Germany, Hermann Oberth taught von Braun all he knows about space and will also consult it to a movie, Frau im Mond, The Woman in the Moon. And of course, after World War II, von Braun led his people to become our Germans, not the Soviets, Germans. And so they came to this country, despite the fact that Truman had said nobody with any Nazi past can ever come here. Innocent biographies for all these people and paperclip them to the personnel files. And then we have Fred Singer and the Mouse, which I read about as a youngster. So there on the left, you see Goddard with his little rocket. On the right, you see a greatly magnified picture of Mr. Fred Singer's concept of a satellite. And he's quite a character, and I'm not going to go into that much. I'll just check from time to time. Are we still together?
Yes, we're still together.
Okay. So at that point, we have to see about navigation, getting more scientific. And Mr. Pitot made tubes for measuring speed, only the speed he was measuring was the speed of barges on French canals. But anyhow, the principle worked and was ultimately applied to airplanes. Radio navigation, gyro compassing were developed again back in this period. And so there was a gyro autopilot by Sperry, and everyone's heard of Sperry gyro. But Mr. Sperry himself was confident enough in this that he had his son do the flyover at the French air show. Draper fiddling with inertial navigation at MIT. Damn.
Oh, we can hear you now, so that's good.
Okay, I'm just noticing. I keep getting. I've got another computer here which keeps telling me about failures. Anyway, so in the 30s, Doc Draper was a very hands-on guy at MIT. He more or less invented inertial navigation, or at least made it real, whatever had been thought about it before. And so I'm going to explain somewhat. Inertial navigation, a dead reckoning carried to electronic extremes. You just measure tiny little accelerations and tiny little changes of direction, and the computer puts them all together to maintain your attitude and your location, your speed. Doc invented something called SPIRE, space something inertial reference equipment, and he flew it to a navigation conference in 1953. And the theme of the conference was, gee, do you suppose the inertial navigation that kind of brought down the house. So, but it's pretty clear that digital computers were going to be the key to success. So we'll talk about computers getting scientific. One of the first electronic computers from Konrad Zuse in Germany in 1936. But of course, all his computers were bombed out of existence by B-17s. In our own Midwest, my connection's unstable again. Well, in our own Midwest, we have John Atanasoff and Cliff Berry, and they put their initials together to make ABC, the Atanasoff-Berry computer. And that's in 39. And George Stibitz made the complex number computer, which is the first one to operate in the cloud. The computer was in, I think, New York City, and the pitch was being given in Schenectady, or maybe the other way around. But anyhow, telegraph wires were used to be a cloud. Everybody who knows about Bletchley knows about Alan Turing and the computers curiously called bombs, which presumably is named for the French dessert. I don't know exactly. And then in a junior officer in the Navy. And she's most famous for her moment with the Harvard Mark II, which stopped with a terrible silence in the lab one day, and the mechanic, the technician, went and pulled a dead moth out of a relay contact. And Grace Hopper instantly says, "Save that. That's history. Tape it to your logbook, and it will live forever in museums." And of course, that's how it came out. So that was the first computer bug, a dead moth in relay points. We have Eckert and Mauchly, who worked on ENIAC, first one of the early defense computers. And then they pretty much stole the design from Atanasoff and used it to start the UNIVAC company. And then John von Neumann in 1948 was the first one to say, gee, you know, instead of having separate memories for program and data, we can make them share the same memory. That makes it rotates and makes contacts that drive the computing steps. On the upper right, you have Colossus at Bletchley. How all those ran without breaking, I cannot begin to tell you, but they did solve all the Enigma series of German codes in World War II. And the long picture on the bottom is the way the Harvard Mark I used to look, and did look in the fall of 1956 when I took my very first computer course at Harvard. You see there's 4 program storages, which are those tapes sort of in the middle. And output is 4 IBM typewriters on the right, and underneath there you can just see some card readers. And so everything was electromechanical. It was the same kind of wheels that IBM punch card accounting machines were made of. So that was put hard to work in World War II. And what I didn't know, nobody would tell me then,
Yeah, you just came back.
Just came back. Okay. All right. Did we get through this last one about the pictures?
Yes, through the pictures onto realpolitik.
Right. Okay. So, so should there be, in terms of World War II, one post for a superpower or two? And so the idea of there ought to be two, but they have to be able to destroy each other. That's mutual assured destruction, which did actually satisfy both sides that neither side could win. And so enemies became rivals, which was a great improvement. On the Soviet side, we had two motivations at the top level, which is Lenin dreaming of world leadership under the Soviet communist system, and specifically under Lenin himself. But of course, he died. And then Stalin's dreams were more of Russian invulnerability. Russia centuries, and so he wanted to make backward Russia a technological superpower. And Sergei Korolev, after Stalin's death, solved Khrushchev's dilemma by saying we can make the USSR supreme in space technology. And so that all started around the geophysical year of the late 50s. And NASA was then born out of the NACA, and JFK set us on the road. So there you see the two approaches: the missile race on the left, and JFK giving his speech. By the end of this decade, we must land a man on the moon and bring him safely back to Earth. So the Apollo project had a large architecture. There are many NASA centers involved. Of course, the big one, as I don't need to tell you, is Houston, and Huntsville over in Alabama for the rockets, and Cape Canaveral, which later became Kennedy Space Center in Florida. At MIT, the instrumentation laboratory, Doc Draper's lab, was the primary contractor.
It looks like we lost them altogether. Oh no, there you are. Just can't hear you.
Yeah, for some reason, my router, when it hiccups, it puts me back in mute, which is, I'm sure, a feature somebody designed in. But anyway, so I was just talking about the MIT Instrumentation Lab as the prime contractor. It was the first contract awarded. It was awarded without any thought of comparative bids or anything like that. And so the rest of the industry didn't care for that very much. Okay, IBM was another major center, working with the von Braun's people in Huntsville, and the instrumentation unit contained their launch vehicle digital computer. And that was a triple redundant computer, serial logic, very, that is just one. But they did have triple redundant redundancy for fault tolerance. And then North American Aviation, for the first two modules to be known about, the command module and the service module. We'll see all these in a moment. And then Grumman Aircraft, after a while, was picked to do the lunar module. They called it lunar excursion module first, and somebody said, well, excursions don't sound very serious. Let's take the word excursion out. So they did. Okay, I keep having to click somewhere. Bing, bang. Okay. So the problem I faced was it's manageable to get people to the moon, but getting them there and something could bring them back was a much bigger problem. And one stubborn guy solved the problem, just going over people's heads and going around the normal protocol and everything. And he finally convinced everybody that the Lunar Orbit Rendezvous, the separate lander, and the Lunar Orbit Rendezvous was the best way. And it simply wasn't riskier than the rest of the mission. So that accounted for the full population of spacecraft. And yes, well,
Well, we could sing the song while we're waiting.
oh, okay, yeah. So anyhow, we figured, by 1968, we might actually be there. So sing a song of megabucks, a rocket full of pie, 4 and 20 astronauts blasted through the sky. When the hatches opened, the taxpayers will cheer. Now isn't that the hell of a thing to do in election year? And so it was. And so it would be, anyhow, and the song is from 1964. Okay, what we had done in the lab previously is we had developed onboard computing for the Polaris guidance, the Polaris missiles, submarine launched missiles. And that was fairly straightforward because you didn't have any human beings on board wanting to do what they wanted to do. But of course, we had that situation here. And this was a cartoon drawn by somebody in the lab technical publications department. On the left, you see the engineer's view. The crew is just along for the ride with looking at the abort button to see whether that.
Yeah, it looks like we lost you again.
Right.
Oh, there you
So
are.
the compromise we finally landed on was, of course, that okay, can you hear me now?
Yes, I can hear you.
Okay. All right. Anyhow, so the compromise that we landed on was that the crew would make the decisions and let the Apollo guidance computer do all the work. And for a little Nova TV show at the 50th anniversary of Apollo 8 at the end of 2018, I was one of the talking heads in that show, and I pointed out that one of the things, one good reason to let the AGC do the work is that if you count the descent engine on the LEM particularly, and you've got 16 little jets, then if the guy's going to do everything himself, he better have 17 fingers and be awfully nimble. So that was certainly a good reason to kind of, if I can get this thing to obey. Yeah. Okay. Anyhow, of course, we started off simply repurposing a computer that we had designed, the first one that had my design imprint, thumbprint on it at all, redesignating it as the Apollo guidance computer. And it soon became clear that that wasn't going to be anywhere near enough. So we redesigned it with advanced technology, integrated circuits, and you get various people give a number of, a variety of numbers. What I remember then is we used 1/3 of all the integrated circuits there had ever been, including some that had been used in missiles. And other people will tell you we use 60% of that year's production of integrated circuits. I think both statements are true. They're just slightly different counts. So that was what we call the block 1. 2 years later, same situation. We didn't have enough memory. We didn't have enough speed. We didn't have enough instruction repertoire. We had some ways to make it bigger. So the block 2 model was about, in terms of just computing power, about 10 times. Okay.
Oh, you're back? Yep.
Okay. Apparently I was out again. Okay, now. Okay. So here's the computer itself. And of course, a lot of people have made some nice YouTubes about the development of the computer. One thing just last night that it hadn't occurred to me with this pitch. You see all that white patch there on the lower left corner of the computer itself. That is the input-output unit. There's hundreds and hundreds of pins there. So the fellow I was listening to and watching said, you know, it's all very well to say that this computer has less computing power than your watch or your iPhone, but if you think about computing power properly, you got to think about connectivity to all the input-output units. And so that's what that kind of emphasizes. On the right, you see the display keyboard, the disk key. Those pads, those keys there, they're about a square inch so that you can punch them while wearing a heavy-duty glove. So that gives you a pretty good sense of the computer itself. Took out 1 square foot and drew about 60 watts, about 1 light bulb worth of power. All of which was, needless to say, utterly unheard of in the 1960s. Okay, here we are. Okay. So when you do celestial navigation in space, we did have a sextant built in, but it worked in a slightly different way. Well, it worked in both the traditional way using Earth or Moon horizon, but you could also use pairs of stars for orientation. And the point is that the sextant was built in with a shaft and trunnion motion itself built into the skin, so that when you got the 2 stars you were thinking up lined up in the 2 line of sights in the sextant, you were not interested in the angle between them, but in how the sextant had to be pointed relative to the spacecraft. So that's how the spacecraft updated its orientation when necessary. Gyros do drift eventually. They need adjusting just about once per day. So we had to have some of the celestial navigation stuff.
Okay, you're back.
I'm back again. Okay. Okay, I'm supposed to be able to do this. Hey, come on.
Actually, I'm sharing out the slides, so if you could just tell me where to go.
I'm sorry, you're doing what?
Sharing out your slides. So that maybe, did you want to go back to the next one or?
Oh, okay. I think we just, yeah, let me just go back to, I say, there is actually a next previous thing here. Maybe that'll work better. Let's see. No, that's not working either. Oh, I'm sorry. We're looking at your screen now. Okay. Yeah. Okay. That's good. I guess I don't know how to relieve the bandwidth problem. I could turn off my video, couldn't I? I'm going to do that. Okay. Now then, you can still hear me, right?
Yes.
Okay. So I'll just give you next slide signals. Okay. So we talked here about how the
Unfortunately, the audio just cut out. Yep.
get that a little bit later.
There we go. Okay, cool.
Okay. So and I did talk about drifting, and okay, I assume that my audio continues through unstable router service here. So next slide, please. Okay, this is the only picture I had to pay for in the book. It's done by a freelance photographer. That's Doc Draper looking just as dockish as he possibly can. This is the roof of the building, 75 Cambridge Parkway. As you see, it's across from the Prudential Tower in Boston. Hancock Tower was not yet built. And above and to the right of Doc's head, you can see a Block 1 sort of primitive version of the Disky with all the places for the buttons and the displays. And right next to it is the mark button. So Doc was able to go up on the roof of the building and get stars in his sights and generally navigate planet Earth, which is quite a treat. Next one, please. Okay, so the space race, and one thing I do in my book is I try to thing says I'm not. Are you hearing me now?
You just came back, yes.
Okay. Okay, so the Russians were the first ones to take pictures of the moon's far side. And for a long time, the X-15 rocket plane was thought to be, it's more like an airplane, so it must be the right way for humans to go into space. And yeah, it works, but just enough to pop your nose into space and come back. But they did that 199 times. The Mercury program had 6 flights, of the first 2 of which were suborbital, causing the Russians to, of course, treat the whole thing very scornfully. Their ship, Vostok, also took 6 flights in the same period. They were all orbital. They tried using cosmonaut intuition to make a rendezvous between 2 spacecraft, and it was a total failure. Just your pilot intuition, even a trained pilot, is not going to achieve rendezvous. And then they announced the Gemini program, which was briefly known as Mercury. Am I coming through?
Yes, now you are.
Okay, good. Okay, so we have some nice pictures here. There is a B-52 dropping the X-15 off, and it's just lighting up its engine, and it will, of course, accelerate very, very rapidly from there. In the upper right, we have a Mercury spacecraft modified for museum exhibit. That is to say, that big square window, I assure you, was not in the spacecraft when it was a spacecraft, but they put it there so that you have some chance of seeing what's inside. Then we have the first Russian one, the Vostok, with its own service module. And then we have Gemini, and what you're looking at here, of course, is Gemini 6 and 7, where they, by using an IBM computer in the spacecraft, they were able to achieve successful rendezvous, though they did not then attempt docking. So next, please. Okay. Anyhow, so here we have anatomy of the Apollo vehicle, starting from the bottom. The Saturn 1C burns kerosene. It has 5 engines at a 1.5 million pounds thrust per each. On top of that same diameter, you have Saturn II, which burns hydrogen, and those engines are 225,000 pounds each. There was once going to be a Saturn III stage, but it became unnecessary, perhaps because the Saturn IV-B, the B model of Saturn IV, was restartable. So it has just one of those J2 engines, and it contains the little ring just above the Saturn II. That's the instrument unit, which is that shape, of course, because it has to fit into the hollow space at the top of Saturn IV's tanks. So IBM's launch vehicle digital computer is all spread out in there, all 3 copies of it. Above that, you have the LEM with its legs demurely folded in its little shroud. And above that, you have the service module with its SPS engine. And above that, you have the Apollo command module, which is the only part that comes home. And above that, you have the launch escape system, which, as you can see, covers the Apollo command module windows on the way up. So those are all the parts. Next, please.
Oops. Let me go back.
Did you do 2?
Friends and domestic enemies. Yeah, it looks like your audio cut out again. Okay, there you are.
So
Briefly. Did we lose them altogether? Nope, still there. Good, good. Okay.
Okay, so all right, yeah, this was the next thing I mentioned before, that awarding the lead contract to MIT was kind of unpopular with industry, and it was unpopular with some people within NASA. So a team came to visit the lab, and their mission was to see whether, in fact, the project should proceed without MIT's participation. So those are the figurative scissors. The meeting was headed by our chief of space guidance analysis, Dick Batten. It was a springtime meeting. The windows were open, and a big old fly, a sort of
I actually read the story in the book. He just takes a pair of scissors and just reaches up and snips the fly in half.
Yeah, yeah. So they never quite recovered their their equanimity, and so they went back and made their report. And the result of the report was that our system was then, they asked us if we could, through the connections with the booster, whether we could back up the function of the instrument unit. And so we did that. And if you imagine how IBM felt about that, they didn't love that very much. So IBM got an independent, independent in quotes, shall we say, consulting firm to make a big report that the right thing to do with the spacecraft was to throw out the Apollo guidance computer and substitute a copy of the instrument unit's launch vehicle digital computer. So all of us who looked at this thing, we looked over the specs of this thing, and we saw that it was by a factor of 3 or 4, not enough computer to do that. So we flew to Houston and played some big D, some real defense there. And so they asked us to read some of our report, and the report starts off saying, "We are astonished that Belcom could have come to this conclusion." Well, there was a really heavy-duty silence for a moment, and one of the NASA guys said, "Okay, I guess we better hear what this is all about." So we then went and made our presentation about how the LVDC was a lovely thing to drive a booster rocket with, but hadn't a prayer of operating a spacecraft. So we survived that one. A little later, we did, when the Manned Spacecraft Center, now the Johnson Space Center, when that was first opened, we got a nice tour of that. And then later in the same year there, JFK was assassinated, and we had our security people over the speakers in the lab said, this is terrible news, and anybody who would like to go home, go ahead, you've got permission to go home. But everybody that I knew about that was anywhere near me said, well, wait a minute, we're working on Jack Kennedy's project. The right thing to do is to press on. And of course we did. So next, please. Okay, so here is, I don't know why I couldn't get a better focused picture, but this is how the Mission Control Center looked then. The row of desks up nearest the screens, that's the so-called trench. And back here, I think, I'm not perfectly certain whether this is a flight director in shirt sleeves right there, or whether I think he's actually back of the thing to the left. So the big screens, well, the room has kind of been preserved anyhow, so you can see it, and it doesn't look much different now, except for, I don't know what they have for graphics. But that's how it looked then. So next, please. Okay, well, Wernher von Braun, of course, wanted to, I think he probably wanted to be an even bigger fish in the Apollo pond than he was. So he thought he would tour the various development centers. And so he came to us, and we had to show him what we had by way of still very much a prototype computer. But we had to do something better than the flashing lights, because that metal box is a pretty boring thing to look at. So he can set the elasticities and gravities. So von Braun played with that for a little bit, and he said, "Oh, that shows their computer is on the ball." And all of us thought, more or less simultaneously, Dankeschön, Wernher, that is exactly what it does. So we got past that one, and the next slide will show you Doc Draper and Wernher von Braun. Doc is clearly explaining, and von Braun seems to be taking it all in. So next, please. Okay, so the next stage in the space race, the Vostok with the one man in the Soviets was replaced by Voskhod, which made 2 flights. And they had either 2 or 3 cosmonauts, and the first spacewalk was taken there. And I believe that was Leonov. Gemini did 10 flights. And of course, the main mission of Gemini was to make sure that we could indeed make rendezvous work. And it did, as you saw in the earlier picture. It also served to show and just right on the edge of unconsciousness, Neil managed to get the thing under control. So if there was any doubt about Neil as super astronaut, it was dissolved at that point. The Soviets had a number of craft they call Luna, and they did manage a soft landing on the moon. And I see somebody's furry beast there. And they also managed to orbit the moon. Now, in 1967, both sides had disasters. Everybody obviously knows, if they have any interest in space, of the fire that killed all three of the Apollo 1 crew. But maybe not everybody realizes that the first flight of a Soyuz crashed and killed its crew, which was just a single cosmonaut at that time. So next, please. So 1968 was a very eventful year. The first unmanned LEM, our system looked pretty crummy because it was they violated the spec and made the thing behave differently and take longer to obtain to get up to thrust. And nobody, there was no chance of making our computer do anything different. So anyhow, that was not our fault. One of my colleagues made a movie to train astronauts, but it wasn't much of a movie, and because it was done with a flatbed plotter, about 2 feet by 2 feet, moving one black pen around. We just did little sketches of moon craters as they would look through the window. In the spring, I got to attend the second launch of the Saturn V with a colleague. And so I was able to stand on the fire escape outside the Launch Control Center, and there was nothing between me and or between the upper half of me anyway, and the rocket, but just 3 miles of Florida air. So I was able to have the full experience there with the sound and the pressure. I don't think anything can reproduce that sound. I certainly felt that, okay, there must be a big sound going on because my ribs are. Had kind of eased off enough that I was able to take up sailing again, and found a nice lady who liked to go sailing, and so one thing led to another, and I got married. So I started working future projects, and Apollo 7 flew. Apollo 7 was just the command module, just the 3 guys in Earth orbit, and perhaps one of them at least, the most ill-tempered astronaut in the whole program, and he did not fly again. At the end of the year, of course, we had Apollo 8, which was going to be 9, but because the LEM was behind schedule, it was moved up. And so around Christmas time of 1968, Apollo 8 went into orbit around the moon, and they read Genesis to the world. And at that point, I say we were ahead for good as far as the moon race went. Okay, just a couple of pictures here. The left is I think that's the view from the tower of the launch that I watched. And on the right, we have the famous picture from Apollo 8 of Earthrise as seen from the moon. Hello, are we together? There we go. Okay, good. So if 68 was eventful, 69 was more eventful. Early in the year, the Apollo 9 crew asked for some training in the AGC software. So, and I was given, a couple of hours to do that after lunch. So I walked into the meeting room there, and the three guys, the crew, McDivitt and Schweikert and I've forgotten at the moment. Anyhow, so I'm lugging this this book, a printout of the source code, the assembly listing, not just the source code, but the full assembly listing, and it's nearly 2,000 pages. So I saw three strong jaws kind of droop a little bit, as if to say, well, looks like we weren't careful what we asked for. What I was able to do was show them through my very elaborate indexing scheme in the back of the listing how to find their way through if they really were curious. But in the end, it was perfectly clear that what they learned was exactly how much there was that they couldn't take time to learn and didn't need to know anyway. So it was a useful session in that sense. And it was also my only go at training astronauts. So they're memorable for that reason to me. Now, the Soviets did some good tricks with Earth orbit. They were the first ones to achieve docking. And what they did after the docking was a crew transfer. One of the cosmonauts climbed out of the Soyuz #1 and crawled along the outside of the spacecraft and got into Soyuz #2. And so he was the first fellow to return from space in a vehicle different from the one he went up in. And then, of course, we had Apollo 10, the dress rehearsal. That went to the moon. The lunar module did separate, and it did go down into its descent orbit, but it did not do the landing. And there was a slightly uncontrolled moment when it came back, and they did the docking, and the crew came back. And so I'll just mention that because Buzz Aldrin am I talking here? Yeah. Okay.
Here we are. Okay, yeah, last minute lessons to apply to Apollo 11.
Yeah. Okay. And so I was just saying that Buzz Aldrin learned something important there, which we'll come to shortly. So next one, please. Okay. In 1969, one of the things that happened fairly early in the year, only we never heard about it. And in fact, it was a deep, dark secret. Any of our spooky spies did. The Russian booster N1 was on its, I think it was the third of the fourth trials, and the booster exploded in such a way as to kill and injure quite a lot of the Soviet personnel involved. And they did make one fourth try later to make that booster do something. This is the one with 30 little rockets all strapped together. And so it was what they knew that we didn't know at the time was that they hadn't a prayer of landing a man on the moon anytime soon, because their booster couldn't hack it. So Apollo 11 went perfectly right up to the descent to the moon. And then we had the a cycle of a job that did a periodic cycle would start when his previous version of that hadn't finished. Nevertheless, for many good reasons, and maybe I'll save this for question time a little bit. For many good reasons, we knew that the right thing to do was, and Steve Bales, of course, sitting in the trench, knew that if the flying was going on, everything was fine. The AGC would reboot itself whenever necessary, And of course, it rebooted very fast, like 1,000 times as fast as the machine I'm talking to you on. Then, of course, we had Neil Armstrong with his famous speech, which was one small step for a man, or maybe just man. And I'll come back to that in a moment. Apollo 12 in the same year was struck by lightning during a boost, and while that discombobulated all the electronics in the spacecraft, it did not discombobulate the launch booster. So they were able to complete the launch and get into orbit. And then we had plenty of time to straighten out everything in the Apollo 12 spacecraft. So we went on, land right on the moon target, better than the first time. And at that point, it became clear that landing Apollos on the moon didn't involve strokes of luck. It's just good engineering. So the moon race is over. Now, what you got here is my speculation. I haven't found enough facts to say for sure this is what it is, but here's what I say is happening. From Tranquility Base on the moon, the words that are spoken include "for a man," and that takes 1,200 milliseconds to get to Honeysuckle, Australia. Now, Australia at that time did not have any undersea cables to the rest of the world. So they had to use Intelsat 3, which was 150 milliseconds away. So the words "for a man" went up to Intelsat 3 just as they'd been received at Honeysuckle. But as they got on their way down, if you will hit the next button, you'll see an addition to this screen. There you go. For some reason, the fellow controlling which audio feed was in use may have, I can't prove it, but I think that this is the simplest explanation I can think of, switched so as to get the audio feed directly from Tranquility Base, 1,200 milliseconds. And so the gap of 150 milliseconds is just enough for the word "a" in the middle, "for a man," for that word to disappear. The 8 down there is 8 milliseconds from Goldstone to Houston. So it's sheer guesswork, but I did write it up fairly carefully in the book. And I have not heard anybody else making what I would consider as good a supposition about what happened to that word. But I do think that Neil Armstrong, the cool cat above all cool cats, says what he means exactly the way he means to say it, and I have total confidence in him. So I think that's what happened. Moving along then. Okay, so there's, I'm not actually sure which flight this is taken from. I think it probably isn't 11, but anyhow, that sort of illustrates the giant leap for mankind, and the flag being held up by its little mechanical strut there. So next, please. Okay, so in 1970 was the birth of the phrase "failure is not an option." Launched at a time called 1313 is bound to be in trouble at some point. And on the 13th of April, Houston, we had a problem. So this was the locked tank in the service module exploding about 3/4 of the way to the moon. The fuel cells stopped supplying water and power, which is their two duties. And what a lot of people didn't know, and some people don't know yet, is that we'd actually prepared for the case that somehow it might be necessary for the lunar module to be the locomotive to get home again. So that's the LEM as a lifeboat. It was a contingency plan, and so now it had to be put into practice. One of the problems with having no power in your command module, of course, the guys, of course, had to spend that the trip home in the lunar module, where they had environmental control. The command module had air in it, but it was without power. It was very cold and very wet, because they had to save the batteries. And the movie of Apollo 13 really showed the story quite accurately. I really liked that. And toward the shortly before entry, I was asked to write a little between the two spacecraft was plenty to achieve the necessary separation. So my code didn't actually have to be used. Okay, so here's again. I don't know why these out of focus. I would have thought the NASA could have cleaned this one up, but as you can see, that bay of the service module has parts all jumbled after the explosion. So that's the record we have of that. Next, please. Okay. So the space race going on from there, we had a total of 7 manned flights for Apollo, including the first and second manned landings on the moon. Soyuz also had 7 manned flights in Earth orbit, and they did a good trick one time. They had 3 Soyuz spacecrafts all orbiting at once and somehow managed to control them all without getting confused. So credit to them for that. There were Luna moonlanders for unmanned flights to the moon, and 2 were supposed to bring back small samples, and one of them, in fact, was specifically set to bring back a small sample but hundreds of miles away. The instruments picked it up, but they did not. They had no particular awareness of it. So one of the Lunas delivered Lunokhod, a lunar rover. So that was the first lunar rover. Next, please. Okay. The next year was certainly better for our side. Apollo 14 had a ghost in the abort button. I'm just riffing off Ghost in the Machine here. The abort button was really a fairly complicated thing, made quite a lot of contacts, but the problem was it had a little solder ball floating around in it in 0G. So at a time when the computer program was not listening to the abort button, the abort signal did indeed come in. But my colleague Don Isles found out a way to fool part of the software into thinking an abort had already started, and therefore it didn't need to look at the button. And so that was the very short story of that workaround. And so Don Isles gets credit from the crew and from the world for saving the Apollo 14 mission. That's the flight. Alan Shepard was along, having, as you and he said it just went miles and miles. Well, later somebody did the arithmetic and figured that 400 yards was about the most he could possibly have done. So you can take a golfer and take him to the moon, but you cannot take the lyre out of the golfer. That's how it goes. At this point, the Soviets started to deal in space stations, which they call Salyut, but Soyuz was supposed to rendezvous with it and failed. The next Soyuz took 3 cosmonauts to Salyut, and they performed a mission and came home. But on the way home, air leak depressurized the thing so that all 3 cosmonauts arrived dead. At this point, in the terms of later projects, I joined a group working on fault tolerance as a particular specialty, and that will become important in a moment. Apollo 15 had a couple of nice firsts, and if you go to the next picture, you'll see them. There's the rover on the left, our rover, and Now, I've got an obstacle. Oh, there it goes. Okay. Anyhow, so what you see is you seem to see a number of differently colored objects flying out for the guillotine chopped all the cables between the ascent stage and the descent stage. The reason for the different colors, however, is that the color TV camera on the rover was the kind that did the colors one by one. So whatever you see in blue flew out in at a slightly different time from the stuff that you see in red. But it was very spectacular to see that live action of liftoff from the moon. Next, please.
Oops.
Okay. So with the moon race kind of not a race anymore, some MIT students, I mean, this was still 1969, so the student, or the 70, I guess I should say, students were very active, and so the students had a thought process which said, but the other lab, Lincoln Lab, it was actually working on missiles. Nixon didn't really care about space. Now, having won the moon race, who cares? And the Soviets continued to shift their focus to their space stations. And then, of course, the space shuttle was announced, and the space shuttle would be so cost effective that people who weren't astronauts could go up in their regular lab clothing, and everything would be super cheap. Well, of course, the Soviets didn't understand the degree to which it was necessary to lie to Congress to get proper funding. So they knew that what was being said was impossible, and that worried them quite a bit. So if we move on. But there were a number of game changes. Nixon at this point reopened relations with China, thereby pushing the Soviets a little further toward the margins. Apollo 16 went to the lunar highlands, harvested a rock called Big Muley. It was named for a leader in the geology training. So that was the best rock. Off against the other. That fits. That sort of fits to me. Anyhow, CSDL, that's us now, the Charles Stark Draper Laboratory. We worked on space shuttle avionics. We didn't get to build anything, unfortunately, despite one of the NASA people told us, wish you could do this, you guys are the best, but they had to let IBM do, essentially run the avionics. And Apollo 17, final manned mission to the moon. And so if you go to the next slide, we'll see the wonderful blue marble photo taken by Jack Schmitt with Africa, Arabia near the top, Madagascar in view, and Antarctica and all that. So that's, I don't know how many more pictures there are that exist that are of this quality, but when you hear about the blue marble, this is the picture they mean. Moving right along then. We put up our own space station called Skylab, and pretty near craft, the whole Apollo system was just a bus you could take to get to the space station. So it was kind of taken for granted. The Soviets put up something called Salyut 2, which was really a fake name because it was really a military thing, but it didn't matter because it was wrecked by depressurizing. And the Soviets put up many spy satellites, but one of them exploded on the launch pad. So it was another setback to them. But they were able to test fly their safer Soyuz design that would not depressurize and kill the cosmonaut. And we began to learn about this shuttle computers that that IBM had taken as being very nearly off the shelf, which is what they're supposed to do, but not quite fully off the shelf. Mouse That Roared referred to a thing I had a great deal of fun with. The IBM people came to MIT and they made a presentation of this wonderful GPC, general purpose computer, for the space shuttle, and told us what its speeds were, and the double precision floating point device.
Hello, Hugh. Can you hear me okay? Hello, Hugh.
Okay, I guess
Oh,
back.
there we go. Yeah, I
Yeah.
can hear you. I was just noticing the time. I wanted to leave some time at for the end for questions. I
Right.
didn't know if you about how many more slides we had.
Okay, we're pretty close to the end. I was just
Okay.
telling how I managed to shame IBM into improving the performance of their divide instruction. So I was the mouse that roared. So moving right along here. Next, yes. Hello, are we there?
Oh, you want the one after Skylab? This one?
Yeah, yes, please.
Okay.
Right. Okay, so there you see Skylab. The crew has had time to put up that little foil parasol. If you want to go back to that one again for the moment.
Oh, there you are. Okay.
Okay, sorry. Yeah, I was just pointing out the sort of crumply foil thing. That was the parasol to keep solar heat from destroying food and other perishables. And there's only one wing sticking out because the other wing was broken at launch. So moving along. But we did have those 3 successful visits to that. And then the Russians put up another thing they called Salyut, but its proper name was Almaz, a military outpost. They just had to deorbit it by firing all the ammo in the gun after one visit. The Apollo-Soyuz test project went on. Everything went much better because we'd left Vietnam at that point. And we had a rule for fault tolerance, and I'll skip that in the interest of time. But we did a lot of interesting things in the fault tolerance dimension. So moving along then. Okay, so there you see it, all our stuff on the left, all the Soviet stuff on the right, and in the middle, the docking adapter. And I'll leave out the story of the April 5th anomaly, which is interesting, but the book does that well enough. So that was a Soyuz 19, and the let's move along to the next one. Hello?
Yes. Apollo and Space Shuttle, or the one after
Yeah,
that?
that's this one. Yeah, right. Anyhow, that was the final flight of Apollo's command module with the AGC. We'd work on the Space Shuttle, and I'll just hasten through. Everybody knows roughly what the space shuttle did. What everybody doesn't know is that the Soviets, being very suspicious, they just knew that the shuttle was a secret weapon. They had no idea what it would do, but they decided, well, we'd better have the same thing. So if you go to the next slide, you will see what they did. That's our shuttle on the top, and that's the Soviet Buran, a Russian copy, if ever there was one, making its landing after its one flight. So they didn't know what the secret weapon was, but they wanted to be ready as soon as they found out. So moving along from that, yes.
As space stations take over?
Yeah. Well, it's whatever's next anyway. There we go. Yeah. Okay. Anyhow, in the interest of cooperation, rather than that somewhat military title Salyut, they called it Mir, which means peace. They abandoned military stations, space stations, finding them to be useless. And so our space station becomes an international space station called Alpha, or ISS. And various countries have joined in, so that space became as international as Antarctica. And that, I believe, that is the last one. If you go to the end there, well, okay, well, that's just it. Nice picture of the space station at the bottom and the shuttle taking off. And that's me on the upper left at a museum in Virginia with the Apollo 12 command module, which is preserved there. And I always liked 12 because that was one that proved to everybody that Apollo 11 was not a lucky fluke. It was all, the success was because we did our engineering properly. So that's it. Questions?
No, sounds good. So what I'm going to do is if everybody could just raise their hand on the, using the little icon in Zoom, then I'll call on you and we could just go in order. Yeah. So if you need any help on the raising the hand part, let me know. Looks like I got a thumbs up, so that's good. So I have a question for you, actually, Hugh. So, as part of doing the development of the Apollo guidance computer and the systems around Apollo.
Now we're back. Okay.
Oh, okay. I had a question for you, Hugh. In terms of, all the development around the Apollo guidance computer and, all the systems that had to be put in place to actually get people to the moon and back. It seems to me that actually helped develop computer technology a lot faster than it would have been otherwise. But now that the space agent, we're using more commercial off-the-shelf technology that's actually, in some cases, a decade or more behind. Do you really see the space program actually advancing technology in the same way it did during the Apollo era?
That's a good question, and I'm going to say I think that certainly computer technology is at a point where it isn't likely to be much influenced by what goes on in space. What we had to do is to somebody characterized our work on the Apollo guidance and navigation as sitting in the 1960s, reaching AGC would probably run it pretty well. So that what we achieved in terms of advancing the computing art was pretty much what you need to be in space.
Well, sounds good. And I see Robin has a question. Robin?
Robin is muted.
Oh, Robin, you're muted.
Yeah, I'm sorry.
Okay.
Just for my knowledge, what technology do you feel advanced us further fastest?
I'm sorry, I didn't something about what technology, but I missed some words there.
What technology do you feel advanced us further faster?
Well, I think one thing, just speaking out for another thing in the computer science area, we had the fact that we had a flexible operating system. Up to that time, real-time computers were kind of like washing machines. The gears went round at one speed, and there was no the restart when it got into trouble.
Would you mind repeating that a little bit? You cut out there for a bit.
Oh, okay. I was just saying that the other factor in computer science that I think we did that advanced us quite a lot, and there are people giving us credit for that today, is a flexible, priority-driven real-time control system. And by flexible, it means it can adapt to interruptions, things that take a little longer than you thought they were going to. Perhaps astronaut user interactions that were more than you bargained for, and so on. And so a lot of reliability of software came from that. Another thing that was important at the time, everybody sees these wonderful pictures of Margaret Hamilton, our sort of chief programmer. And of course, most stuff you read make it look as if she wrote every line of code, which she did not. But she did coin the term software engineering, and to a large extent created software engineering as the somewhat more orderly discipline we at the moment. I'm not. Maybe Robin, if you have a specific suggestion of what you're thinking of.
Oh no, you're just very knowledgeable, and I knew that you could probably define things that moved us forward faster, some
Yeah.
technologies from your great historical and take part in viewpoints.
Yeah. One thing that I haven't mentioned is about the space shuttle. The space shuttle obviously had a lot more room for gear in it. And so it was possible to have actually 5 copies of the general purpose computer, of which one was reserved for a backup system. So there were 4 of them that all had to solve the same problems at the same time. And making that synchronization work, that was a good trick. And we had to take machines that were not originally designed to be synchronized and have them interact in a way that each would come to a kind of checkpoint and look around. Everybody else at this checkpoint, yeah, okay, we'll go ahead. Of course, when a computer on the dashboard to indicate that computer is in trouble. And so that's the way the astronauts wanted to be involved in anything that was like shutting off a computer. And so that's what they did on the ALT #1. So the business of making computers cover every possible discrepancy in behavior, well, every reasonably conceivable one, was definitely, I think we made some big advances there in the space shuttle, and I suspect quite a lot of that. I don't know how that's been used since, but I'm sure it has been.
Can I ask another one? How do you think you have your math degree, and all science is based on math? What biggest application did you use your mathematical degree for the science that you did?
That's kind of interesting. There wasn't there wasn't a whole lot of really advanced math. The biggest deal mathematically, and it's nothing that I had to do very much for doing that digitally, which was known to us at the time as Runge Kutta. These are a couple of guys who worked out how to do digital solutions, sort of advance the solution through time of differential equations. And they were joined by a fellow named Gill, who made the thing a lot more compact. So, but I think personally, my degree, my degree was officially in engineering and applied physics, or engineering and applied mathematics, whichever year that was. But in fact, for all practical purposes, my degree that was useful to me was in computer science. Of course, nobody used the term computer science in those days, but the very first lectures that I had were taught by Howard Aiken himself, left over from World War II. So I was kind of a very early bloomer in terms of computer sciences, and that's why I don't have any higher degrees, any doctorate degrees, because freshly loaded with the skills, I had to get to work, and soon found that the space program was very much the best place to.
Well, sounds good, Hugh. I see we have Ian. You have your hand up. Do you have a question?
Yeah, I have a couple questions.
The computer do what it does and work the way it did. Did use quite a lot of that.
Hey, Hugh, thanks for the speech. This was an awesome presentation. So I have a couple questions. The first one is, with these rockets, you know how there was a difference between the fuel with kerosene and hydrogen? Do the rockets today use that same fuel source, or is it different?
I believe it's pretty much the same. The kerosene is kind of heavy stuff, so you tend to use it on first stage boosters. Although liquid hydrogen is not as light as gaseous, obviously, but the upper stages are carrying hydrogen for their fuel. And as far as I know, that's much the same. There have been some fanciful concepts, like having a big, very strong shield with nuclear bombs going off behind it and pushing the spacecraft along. But this is all pretty much back of paper napkin kind of technology.
Sweet.
And Ian, you had another question?
Yeah, it was more of a suggestion. Could I send Nathan like just a couple other questions and get your input on that, because it's every response is kind of lagging. You know, I'm only hearing like part of the answer.
Okay. Do you want me to repeat some of that?
No, I could hear you fine, but for some of the other questions and throughout your presentation, it was just a lot of it was laggy. So and like it sounded like for the presentation, like you could have gone into like so much details and elaborated on these different events. So
well, yeah, that's why I wrote the book. I mean, making this subject matter fit into approximately 1 hour was not a simple thing to do, and I think we did get it to pretty close to the 1 hour. And yeah, there's just a million details, and occasionally I do help the MIT Museum and various interested people who are telling the story of Apollo. I do get in and help them with some of the details.
Yeah, Ian, if you want to send me some of your questions, I could forward them on to Hugh. That'd be fine. And I've been reading his book, so I might even be able to answer them for you too.
oh, nice, perfect.
Larry, I see you have your hand up. Did you want to ask a question?
Not really. I just had some observations. It's brings me back to when I was young. You showed mission control, but what you should told the people, for every station in mission control, there was a back room with some of them had giant computers in with several people, and there's one room back there where they actually did physical engineering, where they had a couple hundred people in these back rooms.
Yeah, that's true. The big computers, the IBM 360 model, which has gone through various name changes, it was brand new, and the Model 75 was the superest of the 360s at that time, except for Stretch, which is kind of a special case. But there was this huge room with a fair number of these IBM 360s, taking up huge amounts of real estate and requiring lots of people to change disk packs and all that sort of thing. And of course, there were a lot of backup rooms around the periphery of the control center room you saw. And so there was several MIT people.
Yeah, that's a good point, Larry. The people in the mission control get all the attention, but there's like armies behind them.
Yeah, I remember going into one room, we call it what they did for Apollo 13, and they showed this room, and they said that's where all the engineers were going crazy trying to design these things so they could how to get rid of the carbon dioxide. That was hands-on engineering. And I just want to remind the speaker, I says, in the early 80s, early 60s, I was a computer. I was in the Army like that. We used to launch Saturn missiles. For anyone that doesn't know, that was the Army's update to the German V2. And the thing
everything about the big boosters, insofar as the Wernher von Braun had anything to do with them, was obviously founded on what he learned from the V2. And one of the things that he found in when there was a lot of trouble making the Saturn rocket engines, those big F1s, making them fire evenly, was he looked back at the corresponding parts of the V2 and said, "Oh, all right, this plate for the which is sort of got holes."
Oh, we lost him again.
They redesigned the corresponding part of the F1 engine for the Saturn to have that same non-flat pattern, and suddenly it started working.
I know. I just wanted to point out that we call the handicap that you had to work with compared to today. What the computers you had back then, like that, everything that you can get 10 times the power out of your own smartphone now.
Well, that's true. One thing I always like to mention in terms of when people talk about how the AGC has less power than your smartphone is remember that what your smartphone does is it gives you full color, smooth movies with sound. And that's an enormous data processing task. And I'm just guessing, but I like to guess that out of a million things that computer does, all but one of them is focused on drawing pretty pictures and making the sounds. So that a very, very tiny fraction of that computing power is used the way we used it in Apollo. You can certainly tell from the Diski that, we just had these 30-some segments to light up. And so there was practically no processing to produce output that way.
Yeah, when you're actually going to school with computer sciences, when I was in the Army, what we did is we had this truck that used to drive around with the missiles. And our idea of a computer was we had manuals, logarithm books, and slide rules. And if 5 out of the 6 people agreed, that's where we launched. That was our computers.
So, okay, the computers on the ground, of course, that we used for development, for a while, before Apollo started, we were mostly using an IBM 650. And if you want to know what that was, you can look in my book. And then we went to a Honeywell 800, which had some multi-processing power of its own. And that seemed like great stuff for a while. And fortunately, they came out with a 1800, which is 3 times as fast. And finally, we went to the Model 360. I'm not sure which model it was, maybe 67. But we certainly needed to advance as rapidly as possible through our ground computers to advance to higher performance.
Yeah, a lot of these young people don't remember things we used to have. We used to have tubes in the thing, not transistors.
Yeah, that was true of the IBM 650.
Yeah.
And IBM gets a lot of credit for, in that machine, for making these tubes, I'm going to say at least 10, 20 times more reliable than in a lot of other computers. A lot of computers with those tubes, not quite as frequently as we have trouble with this link here, but they'd have to go in and replace tubes more than once a day. And the IBM thing was so conservatively designed that it worked better. But certainly the transistors were and specifically the integrated circuits were the only way to get the reliability that we needed.
Yeah, like I just wanted to say, since I lived in that area, you were on the cutting edge back then.
Yeah.
It may seem primitive to us now, but the thing is, like the person says, whatever we do now, we're standing on the shoulders of giants.
Totally. Yes, indeed. Yeah. And so that's I think why the MIT veterans of this thing, we have reunions about 4 times a year, and some people meet a few more often than that. But it was, the whole thing was such an enormously life-affirming experience that we just get together and live it all over again.
Well, thank you, Larry, for that observation and question. I see David Charant, you have a question.
Yeah, so going back and looking at some of the old computers and stuff, do you remember any uses of an HP 41 calculator in any of the space launches, maybe shuttle or something?
Okay, I see and hear you again, right?
Is that?
I think I finished describing the fact that all us old Apollonauts, we get together frequently to reminisce and live in the past, because that was such an incredible period of past.
Yeah, the question. Yeah, let's see. Question is, do you remember the HP 41 being used in any of the space launches?
41 is a bigger number than I remember from HP. We didn't use them in the lab. I know there was a lot of talk about how astronauts, and I think these were Gemini astronauts, carried an HP calculator like that with them.
Yeah, I remember hearing something about it being used. Maybe it was on shuttle or something, but
well, my guess, I think there was some use of such a gadget in Apollo 13.
Yeah, I think this was a little bit later than the Apollo, but talking about what you can do with a small, the power that we had back then, this one has about the total storage of about 4K split between RAM and.
But yeah, they existed, and they were, of course, very, very new, very limited at the time.
Yeah, well, this
Yeah,
one
see, the 31s only came in during the early 70s, during the Apollo era. So I don't think the 41 was there for sure.
Yeah, 41 probably would have been shuttle. And even at that, let me see, with 4K of combined storage and program space. 4K, I could do a program that did rise and set time, altitude and azimuth for sun, moon, or any planet.
Yeah.
Less space than it takes to save a Word document with one single character in it.
The, hey, the ones in the late 60s were something about the size of what you call a notebook computer now, and you could probably do simple mathematics with them, multiplication.
Yeah.
So you couldn't do a hell of a lot with them.
Yeah, but I mean, like I say, this one had, all the Kepler's equations and everything programmed in it. And, like I say, 4K total space, that's less than the smallest Word document.
Sure, right.
People don't understand
Yeah.
what kind of power you actually had with that little bit of data and RAM space.
I think the exception might be people who used Arduino or one of these microcontrollers. They might have a little greater appreciation.
Even then, they've got so many, many, millions more times of power on it. Did you happen to ever know Ken Cox?
There, testing.
Yeah, did you ever know Ken Cox? Speaking of some of the old.
Yeah, no, Ken was one of the great ones, absolutely.
Yeah, I remember him telling me about making the Lemma lifeboat and trying to get the programming in to do that.
Yeah, he's one of the great ones. Jack Gurman was a fellow that we saw a good deal of. He was sort of a liaison to us, and he's the one who was asked to when NASA suddenly got curious before Apollo 11, got curious about program alarms. The test simulator guy managed to throw one in without having any idea what would cause it. And so Jack Gurman was tasked with making up a table showing what all the program alarms were that were in the code and what they meant and what should be done about it. So Steve Bales had that piece of help, and our people in the back room in Houston had all that too, and so that's why Steve Bales was
Hello, Hugh. You seem to be cutting out a bit again.
okay. Yeah, I was just saying that the that Jack Gurman was our guy for many good purposes, and one of them was he made a handy list of all the program alarms that could happen and what they meant. So when Steve Bales saw the alarm coming up, he says, "Jack, what's up?" And Jack says, "1202, are you flying?" "Yes." "Okay, go." And that's about the time it took to make that decision. That's what it took.
That sounds really good. Hugh, I really appreciate you coming today. Sorry about the technical difficulties. I highly recommend your book to anybody. When we start meeting again at the library, I'll make sure they have a copy so for people to check out. And if anybody else thinks of any other questions you want for Hugh, just let me know, and I can forward them on to him, or maybe in a few more days, I'll be through his book. Might be able to answer them myself, so that's good. But I'll pass the answers by him just to make sure I get it right. I did want to just pivot to one other thing, and that is, I don't know how many of y'all are familiar with Inspiration 4. It's a opportunity that's come up in the past month for 4 people to go to space for a few days on a SpaceX Dragon vehicle. And it was being done as a kind of like a combination of 4 things. Jared Isaacman is the one that's paying for the trip. He's the CEO of Shift4 Payments, and he's doing it as a fundraiser and to support St. Jude's. and he essentially gave 2 of the seats to St. Jude's. One is for them to select a childhood cancer survivor, and who is now also working as a physician assistant. Her name is Haley Arcano, and she'll be going on this flight. Another one is somebody that had donated some money in the month of February to St. Jude through this program. The selection of that person's already happened. It hasn't been announced yet. So it wasn't me. Sorry, I wish it was. But the 4th one is this prosperity one. And the way that they're doing this is essentially you need to come up with a way of using the Shift4 payments and then create an inspirational video. And we have a member of our society who actually has created a video, and I think it's really it's David Gerardo. He's with us now. I'd like to play it for you, and then have him talk a little bit about it if you're up for that. So it's kind of a short one. He's a skydiver, and hopefully the volume is not too loud.
Hi, my name is. Yes, this mission will inspire generations of children, and along with hope, they will prosper and float into their dreams.
Inspiration 4 inspires me to float.
At age 15, I got my first job in this beautiful country while recycling car boxes with my grandpa. Soon after, I was learning English while selling door-to-door. That gave me the chance to make my first investment. Fueled by my life savings, I put my gains into a tire recycling company. We were recycling 650 tires daily when suddenly, on March 10th, 2015, one of the reactors exploded. 3 people were deceased on that day, including my best blood cousin, who passed away at age 28.
My name is David Fernando Guajardo, or David, and I am a skydiver, wingsuit pilot, master scuba diver, and FAA private pilot student. Clevtech was built to revolutionize the Bopil industry. Oriented towards restaurants, the Yummy Box was created from retrofitting green lockers. Imagine being able to walk into a crowded restaurant, grab your order from an insulated box, and go. Since our launch in Q1 2020, we have processed over 5,000 orders with our early adopters. We need Shift4 payments to elevate our mission to the stars and assisting direct customers to have seamless transactions with no human interaction, saving time for both the restaurants and the consumer, while keeping social distancing and hygienic recommendations.
After completing this mission, I will continue sharing Inspiration 4 values globally, starting by visiting my family in France and Mexico.
Avec mes 3 nièces, Marie-Louise, Angelina et Juliette, dans leurs écoles, y con los alumnos de mi hermana Ana Sofía, que tiene maestría en educación.
Commander Isaacman, I am ready to be a part of your crew for this mission.
And I think with that, David, you want to talk a little bit about your video and a little bit about yourself and Inspiration 4, and then maybe we'll open up the questions and see if anybody wants to find out more.
Definitely, yeah, it's my pleasure. So first of all, it was funny when I got noticed about the video because I believe it was you, Nathan, that told me about it. But a few hours ago or days before that, I read about the same contest, but there were other millionaires that are going to the International Space Station, 4 millionaires. So I thought it was that one. And I was like, okay, so that's amazingly cool because I love that, right? But how am I going to participate on that? So like 3 other days happened. And then I noticed that it was an actual contest with a business owner for some of the seats and the other one for the donations. So I decided to make both. And at that time, I haven't even passed my FAA private pilot test. So I was in the final tests and I applied to take the test. And then all of a sudden, the freaking snow happened in Houston, so they canceled 3 other appointments for me making the test. And I really wanted to have that test to show the judges that I already had that, right? So also in my last other 2 scuba diver cards, I got them 1 day before submitting the video. So I submitted the video 1 hour prior to closeout window. I ended up sleeping like 1 hour at night to make the video. So we submitted the video, and I am very, very confident that it is probably the coolest video from the other participants. So you can discover that yourself. I actually invite you guys to go to Twitter and put in the search Inspiration 4 contest and take a look at the other participants. They're gonna be there. They're not at school, and I am glad to mention that we are already in the top 3 most retweeted video. So right now we are at 5,900 retweets, which is cool. And the winner determination, let me tell you guys, because I hope that you guys can get excited as I am, because I believe that North Houston Society, it's very close to get a member to space. So I am very nervous for the last 3 days because we are very, very close. I've already been accepted into the program, and let's see what the judges say. But let me read you the winner determination. So it's gonna be 4 categories. First of all, this seed has nothing to do with why do you wanna go to space. That's why I didn't mention that on the video. And the other participants, my competition, they actually talk about space. I did not talk about space. I decided to put it in my background instead. So I went to JSC Center and NASA, and that's where I got myself in the rocket. The rest of the video, I made it here in my house. And then, so you need to talk about why do you want Shift4 Shop and the billionaire Jared Isaacman to take your business to the stars. That was how am I participating with my business for the restaurants. So there's going to be an independent panels of judges that are going to decide the winner. And these are the 4 categories: inspirational nature of the video, overall entertainment value, entrepreneurial spirit, and the last one, variety of the video. Basically, how many retweets I'm gonna get and how many likes I'm gonna get. And that's why I need you guys to please help me. Don't tell me that you don't have a Twitter account, because it just takes like less than 5 minutes to create the account. And go and tell your neighbors, your friends, your family members, send them the video. It's so cool, it's funny. And we never know, we might have an astronaut from Houston soon.
Oh, we have a lot of astronauts from Houston, but we don't have a lot of astronauts from North Houston Space Society. So
correct.
We might be able to have an astronaut come visit us, but it'd definitely be very unique to have one of our members become an astronaut. But I'd like to open this up. Robin, it looks like you have your hands up.
Well, can you send a direct link to people? You can send a direct link to me with this Twitter thing to make it more convenient. I have found in doing a lot of work that accessibility ensures it being done. So if there's a direct link that can be sent for me to enact on, that would make it a lot easier.
Can we put it in the chat? I was going to ask the same thing. Can we put it in the chat?
Unfortunately, the chat is turned off, and I don't know how to turn it on while in a meeting. Well, maybe I could go to zoom.com and try turning it back on, but I can definitely email it out.
Would you do that?
I will do that for
Thanks.
sure. I'll do that right now. I'll send it to both of y'all. Barbara Brown. Hey, Keith.
I love seeing excitement.
So
Nathan, send it to me too. I'll pass it on to our people.
Thank you, Larry.
At the national level, outside of Houston.
Thank you so much. Thank you so much. And also, I am the only Mexican in the contest. So why not? They need some here in that country, right? Because SpaceX is already with the rideshare program to send satellites. and they want to promote the commercial program as well with Hispanic countries. Even though they are not as rich as the US, they need the more people happy about that, the better. So I hope they choose me because I'm the only bilingual as well. So it occurred to me to also tag the judges in the tweet, in the retweeting. So there's two ways to retweet a tweet in Twitter. And there's one way, just clicking retweet, and the other way is retweet with comment. So if you click on retweet with comment and copy paste the hashtag of the actual judges and the owners, I think that'll cut more attention as well. So I'm gonna send that to you.
Well, Barbara, I don't seem to have your email handy. Maybe you can email it to me, nathan.price@gmail.com, and I could respond to it.
Or I could paste it in the non-existent chat.
Yeah, I know.
We're gonna get you for this.
Are you gonna tell me what it is? But and we can edit it out of the recording. I think.
Yeah, I'll just email it to you. Thank you, Nathan.
Cool. Anybody else have some questions or comments or anything else to share? Well, good.
Hey, well,
Actually, Nathan, I do have a question for the group. Has anybody actually gone down to the coast to watch one of the SpaceX launches?
Yes, I've gone down to the coast to watch the space. Oh, it depends on which coast you're talking about. You're talking about SN 8, 9, and 10?
Yeah, the ones in Texas, not the.
So, oh, okay. Actually, David Jardo went down there and took a picture of SN 8.
I have some friends that work there, and I was there for the 8 and 9. I didn't went to this one because I was getting crazy and obsessed with this contest. I'm putting like 110% of my energy. So yesterday I even went to the doctor. So I'm making calls and sending out email. So believe me, we are very close because the other participants, the stores, they're not good. I mean, one of the girls are selling a hat that says, "Get me to space." So that business is not scalable. That's not scalable. And the other one, which is Emily Calandrelli, I'm pretty sure you guys know who her is. She has a science show in Netflix. So she was selling a personalized video, which, by the way, they already ran out. So they're not selling anything. And those are the only two that are winning more retweets than me. So that's why I'm very, very confident that I'm gonna go, if God willing.
And the reason I asked, David, is because, you know, at Kennedy and at Vanderburg, where I've been, you can watch them without getting invited inside the gate. And I was just wondering if it's worth bothering with the SpaceX ones, or if you have to get invited in.
No, not at all. I actually grew up in South Texas, like a few miles away from Boca Chica. So I know the entire town, and the best place to watch the rocket flow, it is in South Padre Island.
Ah, yeah.
Which
I'm
is
familiar
very
with the
beautiful.
area.
It's very beautiful, that area.
Thanks.
And there's groups of people that are just camped out with video cameras, like NASA Space Flight, I think, is one. And then there's Everyday Astronaut and a few other people.
Those guys, yeah, they always put themselves in a hotel that is behind the Sapphire Hotel. So that Sapphire Hotel, it's the biggest hotel in South Padre Island, and it's going to be actually the same size as the Starship with the booster behind it, which is like 60 floors or 40 floors, something crazy like that, 160 meters high. So they always put themselves there, and I always put myself in another hotel in front of them, which Nathan has a discount code. Maybe you can share it to them, Nathan.
Sure. Yeah. I'd love to take a trip down there. It's just, you know, the timing of rocket tests are always a challenge. You can go, it's important to have backup plans.
So, something else interesting to do besides sitting there twiddling your thumbs?
Exactly. Actually, you know, it's interesting. I talked to one person that lives down there in Brownsville, and he runs like the Astronomical Society there. I think it's the South Texas Astronomical Society. And he says that one of the things that they've been a part of is a beach cleanup on like pre-launch day. So while they're waiting for the launch to happen, they're actually out there doing a community service project.
Oh, I thought you were going to say after the launch because we're such Americans are such trashy people.
Well, or I thought you were making a joke about the debris from the actual test rocket.
Oh, that too. That too.
Yeah. So.
See, Nathan, if you could, I can make an announcement for a couple of events coming up in the next couple
Oh,
of weeks.
absolutely. And if you could send them to me too,
Okay.
I can also send it out in a mass email. But go ahead,
Okay.
David.
Yeah, so we've got in Brownsville coming up next week, we've got the Space Settlement Design Tournament hosted by Expanding Frontiers. And I think you could do a Google search on that, or I can see if I can get you a link for registration for high school students. It's going through the process of developing a proposal like a big company would for a NASA space station proposal. And it's over a weekend time, all online this year. And the following week, or actually in 2 weeks from that, I've got a space settlement entrepreneur competition, which will run concurrently with the Johnson Space Center Space Settlement Design Competition. And in that one, also online, we'll be simulating what it might be like starting a new space company in the 2080s, I think, for that particular scenario. And the companies that are the startups can be 3 to 5 high school or undergraduate students working with a trainer for entrepreneurial type business plan competitions and judges that normally judge business plan competitions. And they may actually be picked by the students doing the design competition to incorporate their new startup company in that proposal. So I can send out the links for that to you if you wouldn't mind getting those
Yes.
out to high school or undergraduate levels.
Yeah, if you could just send me like a little blurb with the relevant links, I could just copy and paste that, put on our website and send it out in an email. So.
Okay, yeah, great, appreciate that.
Cool.
Okay. Well, we're really way over the 4 o'clock mark today, but you know, Robin, I see you have your hand up. I didn't.
Okay. Let's see.
Did you have a question or?
No, I'm done. I'm done, and thank you. I just think it's wonderful. I always feel it's just wonderful to come to your meetings. You've got a full gamut of an audience. I think that you are a great moderator, and Greg Stanley always does an awesome job on the Space News and gives us so much wonderful directed information. I just really enjoy it. Thank you.
Likewise, I feel the same. Thank you, Nathan.
Well, I thank all of y'all, and glad y'all could come, and thanks for spending a little extra time with us. And I look forward to seeing y'all at our next meeting, which is it's going to be April 3rd. So April 3rd at 2 p.m.
And please just share the video that I sent you with your family. Please, I need your help.
Excellent. I've already emailed it out to the people on the call that I had the email addresses for. So
thank you.
That's good. Well, awesome. And well, thank y'all very much. Y'all have a good rest of your day, and feel free to send any questions you have.
Yeah, the thing locks up for
from
reasons other than us.
The talk. And I definitely recommend the book.
This is the router.
I think their router is contributing. Anyhow, I'd like to just join in the praise for this very active club and the things you do. I've very much enjoyed being with you today.
Thank you so much, Hugh. I really appreciate you made the time for us.
Yeah, thanks you. This was an awesome presentation.
Yeah.
Well, okay. Well, I'll talk to y'all later. Y'all have a good rest of your day.
Okay.
Thank
Good
you.
luck, David.
Thank you
Bye.
so much. Check your email.
Good
Appreciate it.
luck.
Thank you. Bye-bye.